Next, uh, the topic of my study is that the determination of crop coefficients using lysimeter for the precision irrigation scheduling. As we know that evaporation and transpiration is a main process when we are calculating the water requirement of the crop. Next, please. This evaporation and transpiration are also depend on the soil surface moisture and wind velocity, water quality, all these things, as well as the physiological condition of the crops. Next, please. The importance of crop coefficients is very much important because of in every irrigation scheduling and design of the project, as well as for the daily irrigation using the drip irrigation or sprinkler irrigation, we have to know the crop coefficients as well as the evapotranspiration of the crops, and whatever the values we are using in India is FAO generated, that is FAO 56 value we are normally using for the irrigating the crop, that crop coefficients. The substantial variation in water requirement during the growing period of the crop is there. Different crops in there. And knowledge of crop water requirement is important for the proper irrigation and proper quantity of irrigation that to be applied to the crops. Next, please. There are different methods that tank and lysimeter experimental feed plot, soil water studies, inflow and outflow method, and analysis of climatological data. Amongst these, the lysimeter experiments are very much accurate, that gives the values of the crop coefficient based on the water balance studies. Next, please. As we all know that the climate reflects on the water requirement, that are the humidity, then relative humidity, minimum, maximum, wind velocity, sunshine hour, and temperatures. As well as it is calculated based on the basis of the graph reference, and it comes to as a we can call it as reference evapotranspiration. Then when we once know the reference evapotranspiration and the value of the particular crop that are growing in particular area, accordingly we can calculate the crop reference evapotranspiration or crop water requirement. Next, please. These are the different, as per the different growth stages of the crop. Normally we are considering the 4 growth stages: initial stage, crop development stage, then mid season stage and late season stage, and that all 3 values are normally used as a average value. But week to week or day to day, that values are changes. That's why there is a difference in precision irrigation management. That's why we want a daily value, or at least for the week of that particular stage, and accordingly we can get the value by using the experimentation, that is very accurate experimentation using lysimeter studies only. Next, please. These data are normally available, or we can calculate from the various data sources which are available to nearby us, or IMD stations, or automatic weather station, whichever available, or SkyMed data is also nowadays it is available, that can be used for the computation of the reference evapotranspiration. Next, please. Once we know this reference evapotranspiration and crop coefficient, we can easily get the crop water requirement, and according to the types of the irrigation system, we can considering the application efficiency of the particular system, accordingly we can apply the particular quantity of water to that crop. Next, please. For that purpose, at Parbhani Center, we have purchased 4 lysimeters for the studies, and on that 4 lysimeters we are conducting throughout the year experimentation for the 5 crops that are selected for the Parbhani station under the project Pokhara project, Nanaji Deshmukh Krishi Sanjeevani Prakalpa. Under this project, we got some grants from the World Bank, near about 78 lakh rupees, and from that we are conducting the experiment. The components of the lysimeters are the inner box and outer box. The sizes are 1.5 meter by 1.5 meter by 1 meter depth. Then weighing indicators are there also. Then collection of drain water, that is for the water balance study, we are calculating the drain water, and weighing indicators for the drain water are also installed there, so that we can get the daily drain water, or whatever the water is drained, whatever the water is stored in the root zone, and whatever water is passed through the environment due to the physiological activities of that crop. Next. Then weighing platform is there. Load cell are itself as given on that platform of the 1000 millimeter by 1000 millimeter, and on that platform the also the data already given there, and it's record the weight, daily weight or time to time weight as reset in the time. We can reset that time from 1 hour to 12 hour also. Accordingly, we can get the data, and that data can be transferred through USB connectivity or the laptop. And control panel of the 400 mm by 330 mm and 260 mm is itself fixed with that lysimeter with the solar panel, so that battery operated. And one more thing is there, the mobile the mobile SIM card is itself given in that data systems, and it reads all the data. One more AWS is nearby area is also located. There is a mobile chips SIM card is given, and it is that data is translocated or the transfer from one to another, and accordingly all these things are recorded there, and that the preloaded program calculate the crop coefficients for the particular hour or particular time period what is set there. These are the installation procedure of the lysimeters. These are the particular size of the which is sizable of the lysimeter is first dig out, and the bricks are laid as a platform, and two tanks are installed here. Next. Also the moisture. This is standard. Okay, next please. These are the complete installations. Next please. These are the equation used for the water balance. Next please. These are the for the groundnut experimentation is carried out. Next please. These are the field view of the groundnut. Next please. All these data in respect of biometric observation, plant height, number of leaves, all were taken for the both the lysimeters as well as the surrounding areas. Next please. This is what as per the standard meteorological weeks, from the data logger, the data is collected, and accordingly the week-wise crop coefficients are drawn in that below graph is shown. Also the crop coefficients and the reference water transpiration shows that during the 14th, 15th and 62 19th week meteorological week, it goes to peak. That is the water requirement during the mid-season stage of that crop. Next. These are the average of these KC values are calculated for the 14th, 15th and 16th week of that crop. Next please. This is the again the average graph of the KC values for the groundnut. Next please. These are the values are compared with the FA value also here. These are the week values, and it shows that it is comparatively higher than the values suggested by FA. Next please. These are the values are summarized in terms of the initial, mid-season stage, development stage, and late season stage values, and this indicates that the FA value are lower as compared to the KC computed for the Parbhani or the semi-arid region of the Maharashtra. These are the conclusion. Crop coefficient values changes from place to place, and the estimated KC value of groundnut at Parbhani for initial stage are also recorded here, and it indicates that the lysimeter KC value are considerably higher for the urban area as suggested by as compared to the AFAO 56 value. Similarly, we have urban station has computed this KC value for the soybean, green gram, okra, and then rabi sorghum. This experimentation is in progress, and urban station has also computed the normalized crop coefficient value for the 14 crops, and that all these values are recently we have given to the development agency Jal Sampada Vibhag at Kinwat at Sahastrakund area. New dam is going to be constructed by the government of Maharashtra, and we have supplied. We are going to supply all these evapotranspiration value for the particular command area as well as the case value of the crop command area. We are going to supply that. Thank you very much.
Thank you.